Good afternoon, everyone. ASME is thrilled to welcome you all to our congressional briefing on managing and rethinking the supply chain. As an organization of over 100,000 members, ASME is proud to provide this forum to share the innovative work being done across the manufacturing industry and beyond to strengthen our supply chain infrastructure and protect against future disruptions. In addition, ASME has worked hard to address the supply chain issues that arose over the last few months, causing global disruptions. We are preparing to release a white paper outlining the hazards of the supply chain, along with a set of recommendations to strengthen our infrastructure moving forward. Today, however, we are privileged to be joined by a panel of experts leading the charge in revamping our supply chain infrastructure. Our first speaker is Mr. William Grieco, CEO of the Rapid Manufacturing Institute. A member of the Manufacturing USA Manufacturing Institutes, Rapid is leading the charge in the modularization of traditional processes, helping our manufacturing industry become more flexible and adapt to an evolving supply chain. Our second speaker is Mr. John Dyke, CEO of SESME, the Smart Manufacturing Institute, also a member of Manufacturing USA. SESME has been a key leader in the integration of data across the supply chain, creating a more resilient supply chain infrastructure. Our third speaker is Dr. Gary Fetter, the Howard M. Wolkoff Professor of Electrical and Computer Engineering at Carnegie Mellon University. Mr. Fetter is also the founding president and up until May of this year served as the interim CEO of the ARM Institute, also part of Manufacturing USA. Our fourth speaker is Mr. Jeff Kent, Technical Director of Global Product Supply Engineering and Innovation at Procter & Gamble, a key player and utilizer of the manufacturing supply chain. One quick note before I turn it over to our speakers, we will be using the Q&A function for all questions located at the bottom of your screen. If you have any questions that arise throughout their presentations, please submit your questions via this function. All right, and on that note, I turn it over to our first speaker, Mr. William Grieco of Rapid.
Thanks a lot, Ann. We appreciate the opportunity to speak to everyone today, and to the attendees, we really appreciate you being here as well. So for the next few minutes, I'm going to give some perspective on the work that we're doing at Rapid to transform the process industries through something that we call modular chemical process intensification. Next slide, please. So Rapid is a public-private partnership between the American Institute of Chemical Engineers and the Department of Energy's Advanced Manufacturing Office. And we're really focused on a couple of critical things. One, we're focused particularly on the process industries because from an energy use standpoint in the US manufacturing sector, the process industries are the largest single consumer of energy. What we mean by the process industries is really any manufacturing operation that focuses on integrated flow systems. So processes that manufacture solids, liquids, gases, the consumables that are used in other manufacturing steps downstream. We're not typically focused on discrete product manufacturing. So no cell phones, microelectronics, automobiles, et cetera. We are focused on the raw materials that go into those other supply chains. Most important though, we're really focused on trying to evolve process design, process development, and process deployment in a way that will enable more sustainable manufacturing that can be flexible, can be robust, and can be resilient to future pandemics, future disruptions like we've seen over the last months. Next slide, please. So what do we mean by modular chemical process intensification? So in our discipline, chemical engineering, engineers have traditionally been trained to think about building larger centralized manufacturing facilities, scaling in volume, building large centralized facilities that take advantage of those economies of scale. In our work, we're beginning to rethink this. We're looking at developing factory-built modularizable systems, so modular plants that could be deployed in a very flexible way. If a manufacturer wants 1x capacity, they put 1 unit in the field. If they want 10x capacity, they scale up in number and get 10x the capacity with 10 units. In our view, this is a real opportunity for enabling distributed manufacturing in industries that haven't typically enjoyed that in the past. Now, process intensification helps underpin some of the modular processing. Again, in our discipline of chemical engineering, we've always been trained to think about unit operations. If you want to manufacture a particular material or chemical, you react them, you separate them, you do heat and mass transfer. And as engineers, we put these unit operations together in very predictable ways to get reliable and predictable processes. To be sure, this isn't going away, but we're bringing a new integrative approach to sort of rethink how these processes and systems are deployed. And one example of that is the transition from batch manufacturing to continuous manufacturing. This is something that is gaining momentum in the specialty chemicals industry, and particularly also in pharmaceutical manufacturing. And it's been very much in the spotlight over the last months as we've seen some supply issues with critical medicines and other materials in the pharmaceutical supply chain. Next slide, please. So I want to give you a particular case study of how we work in Rapid specific to this batch to continuous processing example. So about 2 years ago, we were approached by one of our members, a mid-sized chemical company that was they practice a number of batch processes to make additives for a variety of downstream products. And they serve the fuels and petrochemicals, adhesives, and other supply chains as their customers. They were ready to deploy a capacity expansion. And instead of simply doing a copy of the batch process that they'd been practicing for some 40 years, they had the foresight to say, how might they evolve that to modular processing? So the cartoon on the right-hand side gives a sense of how a company might view taking a singular batch process that produces a certain capacity per year and breaking it down into these modular systems that will be deployed in number, the way I mentioned before. In this particular project, Rapid funded work that was done between the specialty chemicals company and a university to tease out the underlying chemistry and design lab scale processes for both the batch system and then a continuous modular system that produced higher quality product than what they were seeing in the traditional batch process. So what does all this mean? In this project, they went from the lab scale process to the pilot plant with a modular system in 18 months. That's an almost unheard of time frame. It's very quick in the industries that we're talking about. They piloted this modular process for about 6 weeks and then turned it over to commercial operations in one of their existing plants. What they saw was a 90% reduction in capital cost and a 50% reduction in operating cost while driving yield improvement, waste reduction, and allowing for things like just-in-time production, just-in-time manufacturing. We see this as a blueprint for batch to continuous transitions across a range of industries like pharmaceuticals and specialty chemicals. And in fact, it's also a blueprint for how small-scale modular systems might enable distributed and resilient manufacturing in the future. Next slide. Another example of this is around ammonia production. And if one thinks about why would we want to distribute some manufacturing? So ammonia is a chemical that can be difficult to transport. There's some hazards associated with it and restrictions on it. There's certainly a transportation cost in terms of dollars and fuel costs, greenhouse gas emissions, et cetera. A traditional world scale plant is something like what's shown on the right-hand image. That's a large plant built in a facility in the field. That's increasingly being supplanted by modular systems such as the one shown on the left that Siemens or other companies like Linde and Praxair are deploying. It allows flexible footprints, smaller footprints, and in fact could allow manufacturing of the product much closer to where it's used in the field, closer to where raw materials are, closer to where the product is used, minimizing the overall supply chain. So I would say from Rapid's perspective, we see modular intensified processes as a tool to underpin the future of distributed manufacturing, which is inherently more resilient and more robust to the kinds of things that we've seen with the COVID-19 pandemic over the last months. So with that, I'll turn it back to Anne.
Great. Thanks, Bill. And now we turn over to our next speaker, John of SESME.
Thanks, Anne. Our focus here at SESME in partnership with the DOE is on the acceleration of smart manufacturing. And the basic idea that the uninhibited flow of data from real-time plant operations will enable enormous productivity gains in the plant, the enterprise, and of course, across the supply chain. SESME is advancing key enabling technologies for smart manufacturing to enable the next wave of manufacturing and energy productivity here in the US. Next slide, please. These technology, knowledge, and education advancements hold the promise to democratize smart manufacturing and converge the worlds of information technologies and operations technologies, commonly referred to as OT and IT. Next slide, please. Much of the focus and investment in the smart manufacturing value chain is aimed at large manufacturing enterprises, which, by the way, makes up less than 1% of the available manufacturing marketplace. This is an enormous barrier to entry that today makes it almost impossible for small and medium manufacturers to leverage these transformative technologies. We believe that this notion of democratization and of investing in the right ideas like openness, interoperability, crowdsourcing would make smart manufacturing capabilities accessible for most small and medium manufacturers as well. This has the potential to dramatically expand the available market for smart manufacturing from the 1% or less than 1% of manufacturers today to roughly 60% of the manufacturing marketplace. Next slide, please. This briefing today is obviously about rethinking the supply chain, particularly in light of the extraordinary circumstances we face here around COVID-19. But in looking to address these challenges, it's important to recognize that this current crisis isn't taking place in a vacuum. What we're experiencing today shouldn't have caught us by surprise. There's been a storm brewing for some time now, which is critical for us to understand. It's well understood that manufacturing and productivity and innovation is at the heart of our success as a nation. Yet, as we see here, the past decade has revealed an unprecedented plateauing and perhaps even a decline in our manufacturing productivity by worker. We've seen tremendous productivity gains since the 80s, and it might be helpful to understand some of the drivers behind that productivity. There was a real confluence of investment in key initiatives in the 80s and 90s, like Six Sigma, popularized by GE and Motorola in the early 90s, lean manufacturing and continuous improvement really crossed the chasm in the late 80s. ISO standards became broadly adopted by the early 90s. And of course, automation hit its stride in the early 80s and has continued really unabated. That said, why did the productivity curve flatten and then begin to decline? Some would say it's a change in the composition of the manufacturing workforce towards lower productivity work. Others would say that it's a lack of technological progress. I hear speculation about more automation potentially being the answer. And we've certainly heard that the trillions of dollars of value creation around the industrial IoT and AI, machine learning, that is yet to materialize will be a significant contributor. We believe that there are other significant contributors. The investment trajectory in automation isn't really projected to change. The quality and continuous improvement initiatives have reached their own plateau. There's little low-hanging fruit left for those initiatives. And last but not least, digitization efforts, according to many, have reached their own plateau of sorts. Next slide, please. So when this massive disruption materialized, we were left more than a little exposed. This pandemic and the ensuing economic uncertainties have impacted arguably between 75% and up to 94% of the US manufacturing supply chain, most of them negatively. It has exposed some foundational shortcomings and some enormous risks in both our manufacturing operations and in our supply chains. As we look to understand and learn from what we've just been through, how we reacted, how our systems worked and didn't work, how we were able to respond to these dramatic swings in demand, one thing has emerged as a clear call to action. Disruptions in our systems, big and small, require a much more data-driven approach. The quotes that you see here from some of the great manufacturers that are members here at SESME reflect perfectly what I'm hearing from the manufacturing marketplace more broadly. From Johnson & Johnson, understanding the digital stack from sensing to decisions is at the heart of smart manufacturing, and smart manufacturing is the key to developing extraordinary supply chains. Excuse me. From General Mills, as you think about connecting your supply chain to the customer and all the way back to your suppliers, that digital visibility is a key enabler of business success. So far, we've had to do it by brute force and commitment of people. Going forward, we need to be more elegant in our solution. And again, from Johnson & Johnson, a particularly important quote about the workforce stating, "The workforce of today, although incredibly talented, does not have the necessary skills to deliver the agility and resiliency needed, especially in times of crisis, on their own. We must develop more capabilities in data and analytics, connected supply chain, and adaptive process control, think AI and machine learning, to deliver the most critical products in as perfect a fashion, right product, quality, quantity, timeliness, and location as possible." And another data point, a survey done by our friends at LNS Research in looking to understand how manufacturers are responding to this crisis, reveals an aggressive move to close these gaps by investing in smart manufacturing. The top areas of investment, incidentally, included smart manufacturing, the smart connected supply chain, and upskilling their workforce. Next slide. So how do we move forward? How do we position ourselves for an increasingly uncertain future? We see a powerful historic parallel between the national challenges that President Eisenhower faced back in the 50s and where we find ourselves today. He saw a growing nation with a need for new levels of mobility, the need for rapid transport of goods across the country, and for the ongoing security of the nation. President Eisenhower called on Congress to fund the creation of a national highway system, which was approved in 1956 as the National Interstate and Defense Highways Act. We would contend that our manufacturing productivity here in the US is increasingly tied to our ability to enable all manufacturers, all workers, to engage in a new wave of digital value creation. We believe this will be best accomplished as a comprehensive effort to create a national end-to-end supply chain backbone that enables a secure and real-time exchange of manufacturing data between manufacturers and suppliers. This is a digital equivalent to the physical infrastructure that the US funded in 1956. Responding to supply chain disruptions, whether it's pandemic related or more typical day-to-day environments, can't be relegated to using faxes, phone calls, EDI, or emails the way we are today. We have to come up with a better solution. To that end, we've convened a great collection of manufacturers, technology vendors, solution providers, and academia to define this strategy and work together to determine how this can be accomplished. We've been working aggressively to answer important questions like, what is the value of being more connected in real time to my suppliers? What is the value of being more connected in real time to my customers? What are the use cases that we need to solve for? What are the cross-cutting technologies, both operations technology or OT and IT, we need to securely bring this ecosystem together? Can we ensure that the small and medium manufacturing ecosystem can cost effectively engage and then sustain these capabilities? How do we educate our workers en masse to engage in this smart connected supply chain? And last but not least, what will it cost and where will this funding come from? This is a national challenge and one that is best solved at a national level. We would welcome the chance to engage in creative discussions about how we can collaborate with the right organizations and work towards these vital objectives. Thank you.
Great. Thanks, John. Gary?
Thanks, Ann. Can you help me with starting the video? Thank you. Hi, and thanks, Ann. Thanks to everyone for taking the time to engage today on this discussion of supply chain. I'm wearing two caps today. One is faculty director for Manufacturing Futures Initiative at Carnegie Mellon, and also as a board member representing the Advanced Robotics for Manufacturing Institute, which is one of the 8 DoD-funded Manufacturing USA institutes. I got a couple of slides on each of the organizations. This first is where I felt the need to mention the efforts that the Carnegie Mellon Research Enterprise has made, like other universities have, toward the response to the COVID-19 pandemic. Really, I mean, overall, this shows the US capability for innovation during crisis, but also I think it's one of the microcosms that underscores the need for collaboration and coordination when we have these crisis situations. Just to go through this, the first is CMU's Delphi Research Center. We launched something called COVIDcast. It's a site you can find on the internet that tracks COVID-19 forecasting. What's unique about it is it pulls information from Facebook, Google, and local health systems to look at trends and forecasting beyond what you see, for example, from the Johns Hopkins data. It also taps into the Johns Hopkins data. The second is Novid, a contact notification system on your cell phone. The interesting thing here is being completely anonymous tracing with ultrasonic capability. And then, like a lot of other universities, there's a lot of getting together to help, especially in maker spaces, to create personal protective equipment, nasal swabs, face shields, and so on. And also, we had our own local group developing design for ventilators with the local hospital system. The bottom right shows one of the areas that is pretty exciting, that the University of Pittsburgh Medical Centers has a potential vaccine they call PIT-COVAC that is being delivered with one of Carnegie Mellon's microneedle arrays. So these are all areas, again, where the crisis spurs innovation. Next slide. So as part of the Manufacturing Futures Initiative at Carnegie Mellon at the university, we're developing foundations for resilient, what we call resilient cyber programmable factories, as well as wanting to implement this prototype factory at our new facility in Pittsburgh that's co-located with the ARM Institute. As John had just discussed earlier, there's a need for the digitization of the manufacturing line, but it's really in order to create the data-driven approach that's going to help with resiliency. We also believe that the addition of additive manufacturing and being able to reduce part count and work with raw materials, as well as robotics with their versatility, is going to help develop a more resilient manufacturing environment. Next slide. So with the ARM Institute, I've just got a couple slides. One is on our technology investment strategy each year that we put together. We've been, as all the institutes, we have our own focus. Our focus, obviously, is robotics and automation for manufacturing. We've got a consortium of over 240 members pulling from all size companies, including startups, universities, community colleges, economic development nonprofits, but importantly, also across all the market segments, manufacturing market segments in the US, which is really important when you think about resiliency and how can you tap into non-standard supply chains. So the ability to network and connect across the market segments is I think, a critical feature of resiliency in the future. So we're investing in 5 primary focus areas that cut across these sectors. I won't dive into each one of these, but all of these tie in a way to resiliency, both risk reduction, the human-robot interaction, the so-called cobotics is a very important area, how to do that safely. Interoperability really has to do with lowering costs and the ease of programming for robots. The other two, you can see there's 4, the numbers are the number of demos from our projects. 46 of the bulk have been on agility, flexibility, reconfigurability in the robotics work cells, which all speaks to the ability to be able to be versatile in the manufacturing environment. And then the last part is intelligent robotic systems. And this is where the machine learning, the artificial intelligence, and the tie to that in the manufacturing line takes place. I have one breakout I wanted to just call out, which is a company named Vistix, which is a company that makes composite parts, small, medium company in Schenectady, New York. They've got make composite parts through layup and then put these in a hot press molding machine and use a robot to pull them out. They've had large costs and non-uniformities in their inspection process. So through our projects, they developed a way to reuse their robot, not only to pull out the materials from the oven, but then immediately using a change of tool set, use a magnetic Hall sensor to measure the thickness of the material, and do this much more effectively than the workers were doing in terms of coverage, and doing it more uniformly, but more importantly, faster, because you can deal with the fact that the material doesn't have to cool down to the same level. So that with a $9,000 incremental investment, they were able to save 5% cost on this inspection business. But probably more importantly, this raised the quality of their output and is reducing customer returns. So it has these kinds of things have a lot of benefit, and it doesn't require huge amounts of skill to do, but it does require the connectivity and the partnering to get the small mediums to adopt this technology and be competitive. And that's really a lot of what the institutes are about. Next slide. So my last slide has to do with the workforce investment strategy, another facet of the institutes. We have certainly funded a lot of projects, and I'll call out one in apprenticeship in a minute, but I wanted to call attention to our national program to create a competency framework for Industry 4.0 robotics career pathways. We've identified so far 3 primary career pathways for these new types of jobs. We've also tied these to the organic industrial base through the DoD, for example, but this also applies across the commercial sector, robotics integrator, robotics specialist, robotic technician, and they all have different building blocks of knowledge to stack. It's important, the soft skills are there, so there's a lot of cross-cutting with the other workforce training. So we're developing a complete database to tie the people that want the training to the trainers nationally, and also authorize the best trainers to perform that service. One of the big things we've done is fund a bunch of apprenticeship programs. One of the ones I want to call out is AmSkills in the Tampa Bay area. They have a manufacturing skills boot camp that has, I think at their last boot camp, they had 90 folks, and I believe they almost all, if not all of them, got jobs. But there's some wonderful stories of folks who come in that are disadvantaged, they're homeless, veterans, that through these kind of programs, it makes a huge difference. And it really makes a difference to tie to, again, the consortia, the fact that you can cross these sectors in order to tie people to these types of jobs. I think I'll end there, and we'll wait for a discussion later. Thank you.
Wonderful. Thanks so much, Gary. And now let's move on to Jeff Kent at Procter & Gamble.
Thank you, Ann, and thanks to William, John, and Gary for your materials and the collaboration you've had in preparation for the call. First, let me just explain my role. I have a very unique role in Procter & Gamble. Procter & Gamble has been recognized as a supply chain master by Gartner and other credentialing activities. But just 2 years ago, we established an engineering directorate that I have the fortunate to lead called Smart Platforms. So Smart Platforms, as described previously by the other folks, deals with smart manufacturing and smart supply chains and bringing the data intelligence and the technology stack to life against our primary activities in manufacturing and supply chain. So what I'm going to talk about today briefly is the fact that although P&G has been very well set up for our physical supply chains through our customer response network, we still recognize how important data and knowledge is going to be about those supply chains, particularly in the United States, to be able to respond better to either COVID or other disruptions. I'm sure you've all heard in the news how important it was to have toilet paper and other essential over-the-counter remedies. We recognize our obligation to do so. We're going to talk about some of the progressive knowledge and data systems thinking that is going to be important to doing that sustainably for us and to inviting the small to mid-sized companies in the United States to be a part of those successful supply chains. So Anne, if you can go forward. So as we talked about earlier with John and others, you know, we need the physical systems and we need the intelligence, but we also need the knowledge that certain ecosystems bring together. So it's not just about a data system itself, is what does that data represent about the interactions, the functions, how those raw materials are going to compose an actual formula, how those formulas will be part of certain packages and certain finished products as we move them through the supply chain. So a shout out to the work that we're doing with a consortium that's putting together a National Science Foundation proposal for how we would build an open knowledge network that uses technologies like systems engineering, model-based systems engineering, the data that would feed that system, the knowledge about the science, the interactions, and how that all goes together, not just from the R&D aspect, but all the way to the way we manufacture and deliver out to our consumers. We feel like the work that we are partnering with John and SESME is vital for the information superhighway, as John described it. But it also needs to be informed to allow the knowledge transfer between the ecosystem of partners, small, mid-sized, large, and retailers, to know how they're going to participate in the supply chain and then use the data system that will support it. You can go to the next slide. So to make this a little more clear, if you talk about this ecosystem, it is an ecosystem of many things, right? We have PDM and PLM technology to help us to manage the design of our products. We have model-based systems engineering that allows us to manage the requirements and the interactions. We have those modular systems that William spoke about earlier that can be brought together in a as-needed modular way. We have the IoT, which is the sensors and the data that feed the performance and quality of those systems, and then the emergence of digital twins for simulations or how we run the supply chain. All of that has to be orchestrated by a system of knowledge and how that knowledge works together to make a resilient supply chain. So our premise with our partners in the proposal from VCU to Dow Chemical, IBM, Penn State, Tom Sawyer, and Modelon is we need a knowledge network that then complements the digital infrastructure that John is speaking about, that uses the key manufacturing assets that William and Gary are talking about. And we're very vigilant to be a part of that, because if you look at our supply chain, we're world-class, but we're world-class in silos. And we want that to come together, not just inside our facilities, but in our suppliers' facilities to make us a stronger and stronger supply chain, and obviously make a stronger, resilient supply chain for US essential goods. Next slide. So this just builds again one more time on the community that you see here in this call is all working together in a number of ways. We have a National Science Foundation proposal we're putting in. We're certainly working with William and Rapid to make sure that fulfills the chemical and material industry supply chain goals. Yet we're still making sure that we support John and SESME and how we go after the really powerful superhighway of data that would serve all of that knowledge and be executing a very powerful, successful supply chain, and make sure that it doesn't just succeed for P&G, that it succeeds for many of our key suppliers. Our tier 1, tier 2 suppliers are small to mid-sized companies that need to be invited in an affordable, practical, seamless way. So it's exciting that COVID has brought this to attention. Someone like myself who's leading smart platforms for a while, you felt like you were talking a different language. Well, if we were talking a different language, everyone wants to speak this language now. So I'm happy to join this group, and hopefully we can turn over to some good questions.
Okay, great. Thank you, Jeff, Bill, John, and Gary. That was great presentations, and let's just jump right into some questions. So first question is for Bill, John, and Gary. How are the Manufacturing USA Institutes collaborating to drive resilience in manufacturing and domestic supply chains?
So thanks, Ann. I'll kick us off and kind of frame what we're doing, and then Gary and John can chime in. So over the last months, the manufacturing institutes, all of the directors, our counterparts, have crafted a white paper to frame up our perspective on what some of the things are that's needed to drive resilience in supply chain, resilience in manufacturing at the national level. So we're just at the early stages of beginning to socialize that white paper. So look for more information from us on that in the coming weeks. But at the basic level, it looks at how the pandemic has revealed some of the things that John and Gary and I talked about today around supply chain limitations and where resilience is needed. And we're proposing a couple of key things. One, much like Jeff's project with VCU and others, trying to map and understand the current supply chain, where raw materials are, manufacturing, distribution infrastructure is domestically versus internationally, and trying to understand that piece is the first step. And then kind of building a plan for what future domestic manufacturing could look like to prevent the same kinds of limitations that we saw through this pandemic would be the first step. In addition to that, we're starting to think through what are the personnel requirements to respond to situations like what we've seen. So we're proposing a manufacturing guard concept where we would have individuals standing ready to respond to future pandemics. And then lastly, we're thinking about a technology core. So think something like the Peace Corps or Teach for America, but instead aimed at early career scientists and engineers that could be brought into the kinds of supply chain and manufacturing world that we're talking about here. So that's it at a high level. John, Gary, you want to give some more specifics?
John, maybe you want to talk a little bit about the supply chain, some more of the database.
Yeah, in my comments just a few moments ago, I spent a few moments diving into some of those core concepts, the notion that a real-time, end-to-end backbone that allows manufacturers to engage with their suppliers and exchange core touch points, key touch points about manufacturing operations, about their capacity, about their warehousing, about their raw materials. All of those important touch points between producers and suppliers are vital for us to grow in terms of productivity, but also in terms of resilience and in terms of the opportunity to truly react, whether it's an enormous disruption and the sort of simultaneous disruption in both supply and demand that we saw back in March, starting in March, or whether it's a more day-to-day disruption that we need to deal with. So this is effectively, and fundamentally, I'm sure it probably goes without saying that we don't need technology that we can pull off the shelf once every 5 years when we have a massive disruption. We need something that can help us in our day-to-day disruptive environment, that then trains us and teaches us and helps us to enable our workforce to respond when these extreme circumstances show their face. So this is really about a national initiative. At least one of the pillars of this national manufacturing guard story and strategy is about technology backbone, the ability to bring this ecosystem together in a much more contemporary, secure, and sustainable way.
I just augment that the manufacturing guard concept also, you need the data. It's got to be data driven. We've got to have this national coordination, but it's also a people problem. And that's really where the manufacturing guard concept also comes in, of being able to respond in a crisis. We already have a trained set of, these don't have to be CEOs of companies, but the production managers, the mid-level managers in companies that are dedicated to keep things going in the country, having them get together annually to get trained in how the database works, and run these types of crisis scenarios, just like people do all over the country in companies when you run crisis scenarios for, something blows up outside your plant. What do? Well, this is the same kind of thing, but on a national scale. So we can have those people be networked ahead of time. We're going to save weeks, months of time in that gap where, you know, lives can be saved, not just with a pandemic, but this could be any kind of crisis.
Great. That's wonderful. Thanks. Now, Jeff, kind of in follow-up to that a little bit, can you elaborate further on Procter & Gamble's participation in the NSF program proposal for the Open Knowledge Network and how this complements the Manufacturing Guard and Tech Core?
Yeah, sure. As we talked about on my comments, the knowledge has to go with the data, right? The contextual interactions of all the nodes of supply chain and the interactions of the goods, the raw materials, the feedstock. So our participation with VCU and the others that we talked about is really to bring a very powerful concept around model-based systems engineering. We've actually found an essential way that you can really reflect any system and the system of systems as they're combined over the enterprise. And in doing so, the science can be represented, the assets can be represented, the data and analytics can be represented, and then shared out for anyone to participate in it, along with the data models that need to go along with for the data exchange. So we're pretty excited about something that can be that accessible and that extensible for a range of disciplines. And as you know, the supply chain, among other things, is a very multi-domain, multi-discipline challenge, right? Some of the best companies in the world, including P&G, have done very well within certain disciplines. It's, can you do this across the enterprise from the small to mid-size feedstocks all the way to getting it on the shelf? And so systems engineering and our contribution of what we found as a fundamental systems engineering model and model-based systems engineering techniques that we've partnered with IBM, Rhapsody, and Tom Sawyer and others, we're bringing that to this NSF proposal. We've got a lot of excitement from our academic partners, IBM joining, Tom Sawyer joining, and then even William and Rapid being partly there to make sure that it becomes practical for the systems application it needs to serve. So we'll bring some of that also to the SESME and other activities that we're talking about with the National Institute of Standards and Technology. So we think the underlying knowledge platform will be based on systems engineering. We're bringing our know-how to that party.
Fantastic. So kind of pivoting a little bit here, between Manufacturing USA, Carnegie Mellon, Procter & Gamble, you're all bringing different perspectives and skills to the table. Can you speak to the role that each of you are playing in terms of workforce development and educating and training our students to kind of help in these endeavors you've discussed? William, why don't we start with you?
Sure. So each of the manufacturing institutes has a pretty entrenched education and workforce development program. At Rapid, we are developing the underpinning e-learning courses and webinars to teach both undergraduate students as well as graduate students and professional engineers the concepts that I started laying out earlier. The fact is that many undergraduate and graduate chemical engineering curriculum offerings don't have as part of it this concept of modular processing, distributed manufacturing, process intensification, et cetera. So we're building that capability, developing the curricula, deploying it through our own and through American Institute of Chemical Engineers e-learning platform to our constituencies. That's the first part. Second part is that, you know, where we find really the highest leverage is around internships. So we developed over the last couple of years a very robust internship program that puts students into the field, and now actually we're doing it virtually in the time of coronavirus, put students in the field in practical internships with our 80+ members, gives the students field application of their engineering training as well as these concepts of modular processing. And then we overlay on top of that leadership and development training, the same kinds of e-learning curricula that I mentioned before and the concepts that we're developing. And we basically train them and help them mature throughout their internship process. And we've found that it's a way to make students very sticky to industry members, as well as give them the kinds of early career push that keeps them engaged in the kinds of activities that we're talking about here today, designing new advanced manufacturing systems.
So, and I could build even on it from P&G. I mean, certainly we have similar interests for what William is offering in our internship program, but we also recognize the retention and competitiveness of our own employees. So we, across disciplines, across the supply chain, we're investing in upskilling programs, particularly focused on data and analytics. That's no small feat because they're very busy people, but if we intend to be using data and analytics and visualization to drive our competitiveness or resiliency, they have to have literacy. So we're building and applying tailored training programs that they can be taking along with still performing well in their role. So we like what's going on with our students. We want them as our new employees. We want all of them, William, so send them our way. And then we want to make sure our current workforce is prepared for that journey with us. Okay.
Great. John, do you have anything to add?
Yeah, I would add simply that from a smart manufacturing perspective, there's two important aspects to sort of the knowledge transfer, the democratization of knowledge, if you will, in this realm. One is obviously the academic side, whether it's the colleges, whether it's the four-year academic programs that need to understand the key concepts of smart manufacturing, of data structures, of the importance of data models, of the practical concepts behind how systems are implemented, and even the challenges that reside or that exist in manufacturing operations today. On the other side of that is the sort of very complicated, very industry vertical set of manufacturing operations that all have a fairly broad horizontal, potentially have horizontal cross-cutting technology needs and training requirements, even around the basic concepts of, is smart manufacturing important? Is smart manufacturing strategic? How can I relate or tie my strategic initiatives at the boardroom level to the activities and the projects that we're investing in at the plant level or the BU level? So those types of important practitioner to sort of leadership concepts also require, I'll say, vendor agnostic, neutral, trusted third party sort of education to be created and deployed across the country. And that's a big part of what we're doing to augment the student academic side.
Fantastic. Gary, did you want to give the university perspective?
Yeah, I'll try not to be redundant and add. I have a couple points to make. One is on the university side, obviously they have a special role. Their primary role is to educate the undergrads and grad students, but it's really to connect experts in these areas that John and Bill and have already talked about, the need for the experts in AI, machine learning, data analytics, but also ethics and other areas, getting them connected with the folks who do the manufacturing and at the certainly higher educational level, but permeating down, be able to start to make that connectivity. And we're certainly working on that at Carnegie Mellon. I think the other point I want to make is scalability. And it was a question actually on the chat, I think, that came up. How do you make these kinds of things scalable? And I think on the university side, that mainly has to do with, of course, educating our students. They go out in the world and do great things, including startups. But in addition, the outreach we do, a lot of it is train the trainer, and it's creating programs that then are emulated and copied, as opposed to just direct training locally. The same is true in ARM. I mean, the ARM Institute is working on this competency-based framework with the idea that, and we've already developed this, a database and the national curriculum providers and trainers around the nation, and having the ability through the portal to have both the end customer, whether it be the company or the student, be able to tap into that and understand, say what pathway do they want to go on, and then be able to have it recommended. Here's how you can do it, and here's the choices you make. And that's so that we're really tapping in to acting locally, but thinking globally in terms of that communication. Thanks.
Great, that was fantastic. So kind of pivoting back to COVID, looking at the supply chain and the global manufacturing infrastructure, what do you each think the COVID pandemic has altered in the global manufacturing infrastructure and supply chains, of which small and medium manufacturers form a large part? Kind of more specifically, will the changes that we've seen end up being more or less permanent? And if so, can you talk to what each of you are doing to pivot and adapt? John,
maybe I can start from Procter & Gamble's perspective. The response to COVID was clear. I mean, we obviously want to look at our physical supply chain design and then how the data reflects the asset movement. We did so and are doing so in response to COVID, but immediately we've turned the discussion into how is this going to become a competitive business strategy above and beyond COVID. And so what we find is data and analytics are going to be important for the demand signal. So where's the demand coming from? And then when we know where the demand's coming, where might our supply chain be disrupted because of disruptions, either in a local environment or on a country environment or global environment. So we're really putting together our physical supply chain design, our business continuity plans, and the data and analytics to respond on agility. So agility is becoming the word, agility and resilience, so that we can respond to any number of demand signal changes and be able to adapt a particular site's role, whether it be a mixing center, a customization center, manufacturing site, a contract manufacturer, so they can be more responsive to what we do, what we predict as a demand response. So it has to be the full digital twin going along with a really thoughtful physical supply chain and the strategies of each of the business leaders to take advantage of it. So the response for us is we cannot leave ourselves vulnerable so that we can ship these essential goods, and the agility will allow us to optimize our margin even if there isn't a disruption. Okay.
Yeah, and I would add that, and Jeff said something similar before, this has been a catalyst to rethink and reshape the way we do some really, really fundamental things. And the data that I'm seeing, both from Gartner and from LNS, as I alluded to before, points to the reality that the things that Jeff just articulated require, at the very least, two really important things. One is a much more nimble, agile digital infrastructure, and the second is people that are equipped and capable of thinking in new ways. And historically, as we've sort of been poking fun at, have to leave their smartphone and their coveralls in their locker when they walk into the plant, that we believe going forward have to be enabled and equipped to engage in a thoughtful process of what can I do? What can my role be? Am I a citizen technologist equipped to make decisions that will make my company, my product, my process better than it was before? So I think the reality is this is a catalyst. Whether it's sustained or not is to be seen, but I think fundamentally, as we talk about reshoring, nearshoring or reshoring manufacturing, and I think there will be some of that, the more productive we are here in the short to midterm, the more likely that reshoring or nearshoring will happen here in the US. And so it's a vital part of how we move forward from a national defense perspective as well. Not having a significant, vital, agile, resilient manufacturing base here is a risk on a whole bunch of fronts. And so these are all really, really important reasons for us to make sure that we are positioning ourselves for as much of that resilience, nearshoring, reshoring as possible.
It certainly is important from a strategic security perspective. You know, I would add to what both Jeff and John mentioned and say that, you know, as we think about the equipment footprint, the process footprint, traditionally, many manufacturing lines in all industries were kind of a one-size-fits-one operation, built for relative inflexibility. That manufacturing footprint was designed to manufacture product XYZ, or generally just product X. And what we're beginning to rethink is, whether it's modular processing or some other technologies, how can we capture that agility, that flexibility in the equipment, as well as in the supply chain architecture and the data infrastructure? So as we think forward to whatever reshoring or nearshoring might look like, bringing world scale capacity for some things that have been offshored over the last couple of decades could cost tremendous capital investment to firms in the United States. Instead, if we think about smaller scale, more inherently distributed and flexible manufacturing footprint, the barrier to entry for bringing some of that capacity back to the US could be lowered, number one, so the capital cost could be lower. And then I think we can also take advantage of novel systems architecture, novel processes to make those new systems more sustainable, less energy intensive, and sort of have both benefits, the manufacturing, job creation here in the United States, but also reduced environmental footprint, reduced greenhouse gas emissions footprint, and much more efficient processes to make the products here versus elsewhere in the world.
Great, thanks, Gary. Did you have anything to add?
Not really. I don't have a lot to augment. I think what the salient points have been made. I think the idea of agility in the processes is a key one, so that, you know, for the same reason you want to be resilient in pivoting in a crisis, you also want to be resilient when you're, if you have some shutdown in your supply chain, thinking ahead of what is there another way to make your product, for example. And I think the future in manufacturing lines, you know, 10 years from now, will have that kind of agility.
Fantastic. Well, bearing in mind that we're coming to the bottom of the hour, we're just going to end with one final question, which kind of builds on what you've all just been referencing, this topic of resiliency. We're here to examine managing, rethinking the supply chain. John, we'll start with you with this question. Resiliency through data-driven decision-making requires that every participant is willing to share their data in this national network. Can you comment on what challenges you might see in enabling that?
Yeah, that's probably the number one challenge. Actually, there's some enormous technology challenges and cultural barriers and so on and so forth, but we believe those can be overcome. This would clearly fall into the cultural barriers, but I think number one, the value in exchanging data has to be worth the risk and the cost. And given what we just discussed about the need, and the opportunity represented in a more resilient supply chain, which is kind of dictates that exchange of data in a more effective and real-time way, I think the onus is on us as an ecosystem to enable that to happen in a trusted fashion, where the producers and the consumers of that data can, first of all, be assured that the data is secure in every imaginable way, and that only the data that they deem worth sharing is actually available to the network, and specifically for the folks that they deem it worth sharing with. And that's something that we represent a unique opportunity as a private-public partnership to bring about, right? As a trusted broker and as a trusted private-public not-for-profit partnership, we can ensure, we can engage with this ecosystem to ensure, number one, that there's value, number two, that there's trust in a secure and reliable, scalable environment that enables this type of data sharing to happen. They're sharing it today via fax, via email, via phone, via EDI in some cases. We need them to be able to trust that we can share it safely and securely on this infrastructure.
Yeah, so Ann, I would add, you know, from Procter & Gamble's perspective, obviously we're in this discussion a lot, right? We have, you know, thousands of suppliers in the United States and around the world. We have this discussion with our retailers as well, whether it's Walmart or Amazon, you know, what data we share, how we share it, what does it mean to us on our business model, what does it mean for competition? It will be an ongoing discussion, and to John's point, once we understand how the technology can serve us and the data model can be secured and also anonymized in some way, right? To me, this is very analogous to the personal or PPI or personal information, right? If we all stop using personal information because of GDPR and others, we wouldn't have the kind of delighting experiences we have in the social media world. So what we need to do is solve it. And so Procter & Gamble will be looking for joint value propositions with our suppliers as we present this democratized data model and infrastructure so that we all win. And if something puts us too much at risk on a business model, for a supplier, then we need to know about it and try to respect what they can share. But we certainly need to share more, right? And I don't think we should be stopped because there are concerns or things to solve. We just need to solve it in the same way that we still protect people's personal information, yet we still create delighting personal experiences on social media and others. So I think Procter & Gamble is certainly up for the challenge. We're going to need the partnership with John and others, but we'll be probably going at it as a joint value proposition with each of our suppliers and to minimize their risk on their business model for exposing levels of inventory or other substance of interest that are in their materials. But it has to be solved, and we're willing to help solve it.
Terrific. Well, looking at the time, it is 2 o'clock on the dot. So I want to thank you all very much for joining us today. This has been incredibly informative, and we really appreciate it. For all of those who are attending, if we did not get to answer your question, our panelists have very graciously offered to share their contact information with us. So please feel free to reach out to them directly, and they will be happy to respond to any further questions. In addition, a recording of today's event will be posted on the ASME website, so you are able to watch it in the future. With that, thank you so much, everyone. We really appreciate it.
Thank you. Thanks, Ann.
Thank you.
Thanks, Ann.
Thank you.